So here's our first example. Find the area between x equals y squared and y equals x minus 2. All right, this is our first example. Let me make sure that I chose the example that I wanted to. Yeah. Now, there's a first step in figuring these things out, and this is that you must draw a picture. If you don't draw a picture, you'll never figure out what this area is, because you'll never figure out what's what between these curves. The first curve, y equals x squared, is a parabola, but it's x is a function of y. It's pointing this way. So it's this parabola here. That's y equals x squared. Whoops, x equals y squared. The second curve is a line of straight line of slope 1, starting at x equals 2, y equals 0. It goes through this place here, which is 2 over, and it has slope 1. So it does this. And this shape in here is what we mean by the area between the curves. Now that we see what it is, we have a better idea of what our goal is. If you haven't drawn it, you have no hope. All right. Now, I'm going to describe two ways of getting at this area here. And the first one is motivated by the shape that I just described right here. Namely, I'm going to use it in a straightforward way. I'm going to chop things up into these vertical pieces, just as I did right there. Now, here's the difficulty with that. The difficulty is that the upper curve here has one formula, but the lower curve shifts from being a part of the parabola to being a part of the straight line. That means that there are two different formulas for the lower function. And the only way to accommodate that is to separate this up into two halves. Separate it out into two halves. I'm going to have to divide it right here. So we must break it into two pieces and find the integral of one half and the other half. Question?
Selectively using the top half of the parabola. In other words, it's not really.
So you're one step ahead of me. We'll also have to be sure to distinguish between the top branch and the bottom branch of the parabola, which we're about to do. Now, in order to distinguish what's going on, I actually have to use multicolors here. And so we will do that. First, there's the top part, which is orange. All right? That's the top part. I'll call it top. And then there's the bottom part, which has two halves. They are pink and I guess this is blue. All right, so now let's see what's happening. The most important 2 points that I have to figure out in order to get started here, well, really I'm going to have to figure out 3 points, I claim. I'm going to have to figure out where this point is, where this point is, and where that point is. If I know where these 3 points are, then I have a chance of knowing where to start, where to end, and so forth. Another question?
Could you speak up? why do we need to split up that area?
The question is, why do we need to split up the area? And I think in order to answer that question further, I'm going to have to go into the details of the method, and then you'll see where it's necessary. All right? So the first step is that I'm going to figure out what these 3 points are. This one is kind of easy. It's the point 0, 0. This point down here and this point up here are intersections of the two curves. I can identify them by the following equation. I need to see where these curves intersect. At what? Well, if I plug in x is y squared, I get y equals y squared minus 2. And then I can solve this quadratic equation. Y squared minus y minus 2 is equal to 0. So y minus 2 times y plus 1 is equal to 0. And this is telling me that y equals 2 or y equals negative 1. Now, so I found y is equal to negative 1. That means this point down here has second entry negative 1. Its first entry, its x value, I can get from this formula here or the other formula. If I have to square this, negative 1 squared is 1. So that's the formula for this point. And the other point has second entry 2. And again, with this formula y equals x squared, I have to square y to get x, so this is 4. All right, now I claim I have enough data to get started, but maybe I'll identify one more thing. I need the top, the bottom left, and the bottom right. The top is the formula for this branch of x equals y squared, which is in the positive y region, and that is y is equal to square root of x. The bottom curve, part of the parabola, so this is the bottom left, is y equals minus square root x. That's the other branch of the square root. And this is exactly what you were asking before. And this is, we have to distinguish between these two. And the point is these formulas really are different. They're not the same. Now, the last bit is the bottom right chunk here, which is this pink part. Bottom right. And that one is the formula for the line. And that's y equals x minus 2. Now I'm ready to find the area. It's going to be in two chunks. This is the left part plus the right part. And the left part, and I want to set it up as an integral. I want there to be a dx. And here I want to set up an integral, and I want it to be dx. I need to figure out what the range of x is. So first I'm going to, well, let's leave ourselves a little more room than that. Uh-oh. Just to be safe. Okay, here's the right. Okay. So here we have our dx. Now, I need to figure out the starting place and the ending place. So the starting place is the leftmost place. The leftmost place is over here, and x is equal to 0 there. So we're going to travel from this vertical line to the green line over here, and that's from 0 to 1. And the difference between the orange curve and the blue curve is what I call top and bottom left over there. So that is square root of x minus square root of x. Again, this is what I called top, and this was bottom, but only the left. All right, I claim that's giving me the left half of this, the left section of this diagram. Now I'm going to do the right section of the diagram. I start at 1, the lower limit is 1, and I go all the way to this point here, which is the last bit, and that's going to be x equals 4. So the upper limit here is 4. And now I have to take the difference between the top and the bottom again. The top is square root of x all over again, but the bottom has changed. The bottom is now the quantity x minus 2. Please don't forget your parenthesis. There's going to be minus signs and cancellations. All right, now this is almost the end of the problem. The rest of it is routine. We would just have to evaluate these integrals. And fortunately, I'm going to spare you that. Okay, we're not going to bother to do it. That's the easy part. We're not going to do it. But I'm going to show you that there's a much quicker way with this integral and with this area calculation right now. The quicker way is what you see when you see how long this is, and you see that there's another device that you can use that looks similar in principle to this, but reverses the roles of x and y.